Alright, so this LeetCode question is called remove duplicates from sorted list. It says, given a sorted linked list, delete all duplicates such that each element appears only once. The first example is the linked list 112, and the output is 1, 2, because it removes the duplicate 1. And then the second example is 1, 1, 2, 3, 3, and the result is 1, 2, 3, because it removes the duplicate 1 and the duplicate 3. So when we start out, we already have a variable called head. So I'll just name it h to save space. What we need to do is we need to have another variable called current. And current will be whichever linked list node we're on. And I'll denote that by the letter C. Alright, just to show you how a linked list works, each one of these is called a node. And each node has a val property that is associated with the number in the drawing, and a next property which points to the next node in the linked list. And when you get to the last node, you know it's the last node because it has a value like everything else, but its next node points to a null linked list node. Alright, so now that we know how a linked list works, let's begin. So as we said before, right now head and current are the same. We're going to keep head in the same place, but we're going to move current along the linked list, and I'll show you why. So right now, what we have to do is we have to check whether current.val is the same thing as current.next.val. It is, so what we have to do is we have to reassign current.next, which is pointing here, to current.next, which would be this one, .next, which would be this one. So now what you'd see is you'd see current now pointing to 2. All right, let me clean this up a bit. Okay, what's the next step? In order to do the same comparisons later on in the linked list, we have to reassign current to whatever is now current.next. Current.next is now 2, so now we move current to here. Now we do the same thing. We check if current.val equals current.next.val. It doesn't, so in this case we don't have to change its next reference. So all we have to do is change current's reference. So now again we change current to be whatever current.next is. Alright, now we do the same comparison. Does current.val equals current.next.val? It does, so now we have to skip over its next reference by pointing to its next reference. So again, its next is 3, so we have to do next.next, which is null. Which would be this. Again, let me clean it up. And now we're done. Why? Because current is not null, but current's next reference is null. So now all we have to do is redraw the linked list to make it clearer. So head is 1. Its next reference is now pointing to 2, whose next reference is still pointing to 3, whose next reference is now pointing to null. So this would be the answer with the duplicates removed. Alright, so let's start with what LeetCode has given us. It's a function named delete duplicates, which accepts a head. And the head is just the head of a linked list, and it represents the entire linked list. It's not just the head. Alright, so if we look to the left, let's look at the diagram with the arrows. So the number 1 represents the head of the linked list. Then it points to another node that has a value of 3, which points to another node which has a value of 4, which points to another node which has yet another value of 4, which points to null. And if we want to see it represented another way, let's look all the way up above. The first node has a value of 1. And what does it point to? its next property points to another node that has a value of 3, what does its next property point to? Another node that has a value of 4, which points to another node which has a value of 4, which points to null. All right, so let's start. Remember, the first thing we have to do is we have to keep track of the current node. So I'll just put that here. Let current equal head. Now we have to loop over the linked list. So we'll say while current doesn't equal null and current dot next doesn't equal null. And I'll show you why that's the case. So it's pretty obvious that if current becomes this node, that we're done, right? But we'll also be done if current ever becomes this node. And why is that? Because we're at the last node with the value, which means we can't remove any more nodes. All right, so let's get rid of that. Okay, now let's do the comparisons. First one, if current.val, so if current's value equals current.next.val, meaning the node that it's pointing to, does it have the same value as the current node's value? What would we do? We would skip over the next node. But in our case right now, current's value doesn't equal the next node's value, which is 3. So we'll go into this else statement. We would say current equals current.next. So current would now be this. Then it would start the next loop and do the same comparison. Does current's value equal the next node's value? Current's value is 3 and the next node's value is 4, so no. So again, it goes into the else statement and reassigns current to the node that current is pointing to. Then it goes to the next loop in the while loop and it asks again, does the value of the current node equal the value of the node that it's pointing to? Yes, it does. So in this case, what do we have to do? We would have to reassign current's next property, not to the next node, but to the node after that. So it would look something like this. Instead of pointing to 4, it would now point to null. And let's do that above. So current.next, so current is 4. Current.next will no longer be this. It would look at what its next property is and reassign it to the next property after that. And in the code, that would be current.next equals current.next.next. But notice at this point, we haven't actually reassigned current. That comes in the next loop. So remember what the while loop checks. It checks whether current doesn't equal null and current.next doesn't equal null. At this point, current.next actually does equal null. So it breaks out of the loop. And now that we've broken out of the loop, let me just redraw what the linked list would look like now. So 1 points to 3, which points to 4, which points to null. And then we return the head. So return head. And remember, head isn't only the head of the linked list. Since it's connected to every other node in the linked list, returning head returns the entire linked list. All right, so now let's see how we did. Looks good. Submit it. All right, so our solution was faster than 93% of JavaScript submissions. So as usual, the code and written description are linked down below. See you next time.